it is still important to consider the degree and the leading coefficient because it will help us, first of all, to make sure that we entered it into the calculator correctly, because if we're relying on the calculator and we do one little itty-bitty thing wrong, it would throw off the entire graph. So in this particular polynomial, the degree is 3, that is an odd degree, and the leading coefficient is -1, that is negative. Because the leading coefficient is negative, the right side of the graph should point downward. Because the degree is odd, the left side should do the opposite thing. So the last time we took notes, we were talking about this is what the ends are doing. We don't care what's happening in the middle. Well, now we care about what's happening in the middle. So in your graphing calculator, go to y equals. Y equals is where you enter equations. Now look up at my screen. Do you see how plot 1 up at the top of the screen is highlighted? That's bad. That's going to screw up your graph. So if you have any plots highlighted up above, arrow up and potentially arrow over if you have plot 2 highlighted and hit enter, and that will deselect those plots. So you want to make sure those plots are turned off. Highlighted means they're on. They will screw up your graph. Off is like this, not highlighted. Everything looks good. Okay, in y1 equals, we need to plug in -x⁻³. Anytime it's negative and not minus, you need to use the negative button at the bottom of the calculator. So negative, do you remember where the X button is? Right next to the alpha button is your X button. I just highlighted it in red by pressing it. To raise it to the third, we need to use the caret button. Do you know where the caret button is? Directly above the divide. Now, when you raise it on a newer calculator, when you use that caret button, it actually shoves your cursor up into the exponent. So enter your 3, your exponent of 3, and now notice my cursor is still stuck in the exponent. Before you continue on, you need to hit the right arrow to bring your cursor down out of the exponent. Plus x. To enter squared, you could do raised to the second, or there is a fancy square button that just saves you a button press. Plus 3x minus 3. To look at your graph, what do you suppose we're going to press? Graph. Hit graph. Now, if your graph looks funny, if it's not centered, you can push zoom, which is the button in the middle, and then say standard. Find the one that says standard, and that will reset your screen to -10 to 10, -10 to 10 on the graph. But hopefully someone else has used your calculator recently and left it in standard. So this is a chance for you to check, did I enter this correctly? My left side should be pointing up, my right side should be pointing down, and then there's some stuff happening in the middle. Now we could just go to our graph and go, and just draw something in quick. Or we could make this a little bit more accurate, and since we're using the graphing calculators, let's use all of the features of the graphing calculator. Directly above the graph button, it says table. So push second and then your graph button to go into the table. Now yours might look a little bit different than mine. You might have different numbers in the X column. You can use the up arrow and the down arrow to move that around. I'll look at that calculator in a minute. Okay, now looking through here, do you think I'm going to try to graph the point -5, 132? No, because I would have to massively change my scale and that would not be okay. So those of you whose calculators are currently working, let's record a couple of these points on your little table and then graph them. So -2, 3, -1, -4, 0, -3, 1, 0, and 2, -1. Those are the ones that are going to fit. So take a moment, put those points on your graph. Okay, now if you don't understand how graphs work, you might look at these points and think, oh, I see like a greater than sign. It's like an arrow. That's not how we connect the points. We have to connect the points in order. So -2, 3 has to connect to -1, -4, which has to connect to 0, -3, and so on. We have to connect them in order. And like I said earlier, back in my day, I didn't have the pretty picture on the graphing calculator to help me. So you really had to rely on what the end behavior was going to do and then try to connect those points in order. We, however, have the graphing calculator to help us. So I go back to my graph, and it looks like this point down here. Do you see how just after -1, -4, it looks like it bounces just a little bit below? So I'm going to try to mimic that. So this graph's going to come down through our first point, go through our second point, and then kind of bounce up. And then after this point, it kind of bounces around and then goes down. So I'm going to go up through that one and then bounce and then down. For example B, go into y equals, clear out the old, and start entering that new one. X to the 4th minus x to the 3rd minus 4x squared plus 4. See if you can enter this polynomial, look at the graph, look at the table, write down a few of the points that'll fit, plot it, see if you connect the points. I'm going to give you about 2-3 minutes to see if you can do this on your own while I'm here to help you. Okay, here's the equation entered in the calculator. I'm going to go into my table, second graph to go into the table. My points are -1, 2, 0, 4, 1, 0, 2, -4. Now keep in mind, I picked graphs, like I picked polynomials that you should be able to graph fairly easily. So if you're struggling with where the points are that you need, look for the x value of 0. There's probably a couple points around. Now I do want, again, the back in my day. So back in my day, I had to take -1 and plug it into the polynomial to get my y value. Plug in 0, plug in 1, plug in 2. We are letting the table feature of the calculator do all of that math for us, which will hopefully decrease the amount of errors. If I look at the graph, as it's graphing, my degree should be even and my leading coefficient is positive. That means both ends should point up. Do both ends of our graph point up? Yes, that means we probably entered it correctly. Even though you don't technically need to think about that because the graphing calculator is doing everything for you, it is important to think about it just as a way to check. Did I enter this correctly, or did my finger maybe mess up and I put something in wrong? So -1, 2, 0, 4, 1, 0, 2, -4. Now, if you did not have a picture of this graph, it would be really difficult to connect these points. But if you look at this graph, the point -1, 2, do you see how the graph bounces at that point? It's like there's a little mini parabola at that point. So the graph comes down and bounces on that point. And then at 0, 4, it bounces again. Then it comes down through this point, and it looks like it bounces just a little bit before that one and comes up.